Hello all and welcome to this decision analysis under uncertainty lecture notes. And we have finished part 1, leading examples, and we now start part 2, decision matrix techniques. So this part has no examples, it's theoretical, and we start with chapter 3, episode 1, decision matrices and rules, and episode 1 is static setting. So what do? We consider decision matrix problems that are static in their nature. By static, I mean that the decision is done only once, and once the decision is done, we see the consequences. So the decisions do not affect the scenarios or their probabilities, and you could say that in some sense there is no time dimension or cause and effect here. And the simplest way to understand the decision matrix technique is the following. So first, you yourself choose an alternative AI from the set I is an index set capital I, so capital I is 1, 2, 3, 4, 5, 6, 7, and so on, how many alternatives you have. So if you have 3 alternatives, then I is the set of 1, 2, 3. Okay, once you have chosen your alternative, then the lady, the goddess of chance, Lady Fortuna, Fortuna Brevis, chooses scenario Sj from the set Sj, and J belongs to again some index set capital J. So if there are 4 scenarios, then the capital J is the set of 1, 2, 3, 4. And moreover, the scenario Sj is chosen with the probability Pj. And if this happens, so you choose AI, and the goddess of chance chooses Sj, then you get reward Rij. All right, this is the setting in its simplicity. So a small remark here. Sorry about this. So a small remark in the language of probability theory. So if you remember your course on probability theory, there were random variables there. So in this setting, in the language of probability theory, the scenarios form a probability space, usually denoted by capital omega. So capital omega is the scenarios Sj. So these Sj's are what in probability theory are called small omegas. And the alternatives AIs, they are random variables from this probability space omega to real values. And what are their values? So AI, if Sj happens, is just the reward Rij. And the probabilities are, so the probability that AI happens to get the value Rij is Pj, which is also equally, we can say that Pj is the probability of the scenario Sj. So now we have scenarios, we have alternatives, and we have probabilities, and we have rewards. What else do we need in this decision matrix business? We need a value function. A value function, which is also called the decision rule, is just any function v from I to R. So this associates the alternative AI with the value vi. And this can be any function, to be honest. But of course, some value functions are silly, and we will later see some non-silly value functions, something to choose from. And then a decision rule, which is all basically same as value function, but there is an additional thing there. It's either minimizing or maximizing the value function. So the decision rule, how this decision maker reacts to uncertainty, is that first the decision maker decides a value function, and then the decision rules is so that she wants to either minimize or maximize the value function. So strictly speaking, decision rules and value functions are different things, but we will use them synonymously anyway. Okay, a little bit more notation here. So if the decision rules of maximization form, it means the decision maker will choose such an alternative A star, which is A of I star. So this is just notation for which the V of I star is the maximal value of all these VIs. So VI is the value of alternative I, and maximum IVI is the maximal value. In other words, again, just notation, I star is the argument maximum I of VI. So this argument maximum picks up the index I for which this VI is maximized. And again, it should be noted that the optimal alternatives A star may not be unique. There could be many different alternatives that are equally good or equally best, and in that case, just one is chosen at will. So maybe by using a coin flipping, if there are two, and if there are three, then you flip three-sided coin and so on. Similarly, if the decision rules of minimization form, this means that the decision maker will choose such an alternative A star, again, just notation A I star, for which the minimum of I over VI is this VI star. In other words, using this inverse or the minimization function, Argus minimization, argument minimization, I star is the argument minimum. So the argument I for which the VI attains its minimum. And again, it may not be unique, and if in the case of non-uniqueness, one optimizer is chosen at will. That was all in this episode. Thank you for listening. See you in next episodes. Bye.